Okay, we're going to pick up in this video with looking at using the yield curve to price bonds. To this point, we've used a constant discount rate for cash flows of a bond across time. So we've used one discount rate for all the different cash flows across the life of a bond. We're now going to use the yield curve to use the appropriate discount rate for each particular cash flow that is received over the life of the bond. And the reason we're going to do this is because a bond is really equal to a series of zero coupon bonds that are stuck together, each with the cash flow that's maturing at different points over time. So for instance, if we're thinking about a 3-year bond with a 6% coupon, it's really the same as a 6-month zero coupon bond that has a $30 par value, a 12-month zero coupon bond with a $30 par value, a 18-month bond, zero coupon bond with a $30 par value, etc., getting down to the last two payments where you have a 30-month zero coupon bond with a $30 par value, and finally a 36-month zero coupon bond with a $1,030 par value. Let's go to Excel and maybe we can see that visually. So here are the cash flows that you're receiving, and you can really think of these as a series of zero coupon bonds maturing in these particular periods. So just like I was saying, in period 1 we're going to have a zero coupon bond that matures that has a par value of $30. The second cash flow from that bond we're talking about is going to mature in 2 periods, and again we're going to get a $30 payment. We could think of it as a 2-period zero coupon bond that has a par value of $30. So what we're going to do with this, using the yield curve to price bonds, is use the discount rates, use the yield to maturities that correspond to different points in time, different periods, and we're going to use those to discount the cash flows, the appropriate number of periods, at that appropriate rate, and we'll come up with a value. So for instance, we've got the discount rate, or the yield to maturity, again those are synonymous, yield to maturity of 3.33% that corresponds to 1/2 year out, all the way up to 5.05% that corresponds to cash flows that are received 6 periods out, or 3 years. Here's a graphical representation of the yield curve for this particular bond, this particular series of cash flows. And so we're going to use these discount rates, these yield to maturities, to discount the cash flows that we're receiving from our hypothetical 6% coupon 3-year bond. So here are the periods for that 3-year bond. Here are the cash flows. And what we're going to do is just discount the cash flows, and I'm using a formula here in Excel. I'm taking the present value, that cash flow, and then discounting it back the number of periods at half of that, the 6-month rate, looking at the yield to maturity. That yield to maturity is an annual rate. We're going to take each of those in half and then compound those the appropriate number of periods. So when we do that across the 6 cash flows and add them all up, we get a bond value of $1,028.56. Now there's 2 things I want to point out here. The first is that this price is different than if we use the 5.05 yield to maturity, 5.05% yield to maturity, that corresponds to period 6. That's where many times we'd want to look and say, oh, this is a 6-period bond, a 3-year bond, the discount rate out there is 5.05%. Let's use that rate to discount all of the cash flows, and in this case that would be inappropriate. We want to use the discount rates that apply to the particular cash flows over time. So if we used the 5.05% rate, and that's what I'm doing here, plugging that in as the discount rate for this bond, the number of periods is 3. In pricing, we're going to use the present value function. I adjust all of my inputs, put in 5.05% as the discount rate, and my price comes up to $1,026.14, which is different than the value of the bond, than what it should really be worth. It's off by about $2.50. So it's not appropriate to use that one yield to maturity to discount all of the cash flows of the bond. The second note I want to add is that the yield for the bond is still determinable. That is, we can still calculate it based on the price of the bond and all the cash flows, but that yield, the yield to maturity for the bond, is going to be different than the mix of all the different yield to maturities for the cash flows of the bond. So let's just look at this. We've got the price, we calculated that up here. We know the future value, we know the number of periods, and we know the payments, so we can solve for the one rate that makes all that math work out. Now it turns out that this one rate is nowhere on our yield to maturity. There's no cash flow that earns that, but that number, that 4.964%, captures the essence of the returns that we're getting over the life of this bond. So yield to maturity is still an important number, still something we're going to talk about. We're just not going to use one number now to determine the price of the bond. We're going to use this variety of yield to maturities to do that. All right, let's move on and talk about spot rates and forward rates. So spot rates are the rates that we can observe or measure today. Note that we can see spot rates for future periods. That is, we can look today and see what the spot rate is for a 6-year bond. A cash flow that's going to be received 6 years out there. We know what the discount rate is today for those cash flows that happen out then. Now, a forward rate, on the other hand, is the rate that is expected to be prevalent at some point in the future. So that is, we might talk about the 2-year rate 3 years from now. So let's just look at an example real quick how that would matter, where that would come into play. If I buy a 12-year bond, but I only have a 5-year investment horizon, whenever it comes time for me to sell that bond, I'm going to care about the 7-year rate, because then my bond will at that point be a 7-year bond. So what I care about is the 7-year rate at that point in time. And so the forward rate, I could look today and say, in 5 years, what will the 7-year rate be? That would be the forward rate that I'm concerned about. So we're going to look at how to calculate a forward rate, and I want you to keep in mind this big picture, that we're going to end up in the same place financially whichever route we take. And we're going to always look at 2 different routes to get to the end result, the end time frame. So again, this is probably best seen in an example. If I purchase a 3-year bond with a yield of 3.5% per year, or I look at a 1-year bond with a yield of 2.95% and then piece together a 2-year bond on top of that, the question is, what yield should be on that 2-year bond, and in particular the forward rate on that 2-year bond, because I'm thinking about getting that bond 1 year from now. So it's a forward rate that I'm concerned about, and in particular it's the 2-year forward rate 1 year from now. So let's go to Excel and look at this again, and it helps to see the picture, I think. So we're going to look at one route that we just talked about is turning that $1,000 into 1108.72, because we're going to be compounding it at 3.5% over 3 years. So if you look at this cell here, it's just going to be the future value formula. I'm taking the present value of 1,000, I'm growing that at 3.5% for 3 periods, compounding at 3 periods. So it's going to turn into 1108.72. Now the second route is to cobble together a 1-year bond and a 2-year bond. I already told you what the interest rate is for the 1-year bond, and it's 2.95%. So that $1,000 is going to grow to $1,029.50. If I look at the formula there, that shows where that number is coming from. And the last piece here is that I need to turn that $1,029 into 1108. And I'm going to do that by investing it over 2 years at some rate. And that rate then is our forward rate. It's the 1-year, it's the 2-year rate, I should say, 1 year from now. And so that's what we're trying to figure out. And we can use the time value functions. In this case, we're going to be solving for rate. I know the input is, I'm starting with the 1029. It's going to grow to 1108. So that's what's showing up over here. It's going to happen over a 2-year time frame. There's no payments happening in the interim. And so when I solve for the rate, I get 3.776%. So that's the rate I need to have and earn for 2 years to get to the same place. And the key idea here is that we have this arbitrage notion that no matter which way I go, I have to end up in the same place, or else I'm going to pick the route that is more advantageous, and by taking that route, it's going to change the pricing, change the yields, and it's going to force these 2 paths, these 2 routes, to the same number, to the same ending result. Now there's a second way to calculate this. This is more in line with what the book shows. Let me just do another example and talk through this real quick. I can purchase a 5-year bond with a yield of 5.99%, and again that's a per year number. If I can get a 2-year bond today with a yield of 4.77%, what rate will I need on a 3-year bond 2 years from now? Alright, so again, I want to end up in the same place. I'm going to cobble together the bonds to get to 5 years because that's what my first option, my first path will do, is take my money out 5 years. And so this is telling me right here, this calculation, what is $1 going to turn into in 5 years if I invested at 5.99%. So that's what that formula is saying. It's the future value of $1 compounded at 5.99% for 5 years. This is what happens with my 2-year bond. It's going to turn into $1 and a little over 9 cents. And so what I have to do is turn that $1.09 into $1.33 with 3 more years of growth. And if I come down here and do this little division, I get the return I'm going to have. It's basically a 21.85% return over 3 years. If I come over here and solve for the 1/3 root of that number, take away 1, it's another way of telling me I need to get 6.8105% for 3 years, each year on the 3-year bond, and that's going to be the 3-year rate 2 years from now. Let me just quickly show you what we could do with the present value, the future value, all these time value money inputs. If I went back over here and I said after 2 years I'm going to have this, I need it to grow to this. I'm going to do that over 3 years. I have 0 interim cash flows if I solve for the rate. I'm going to get the exact same answer, and so it doesn't really matter which way you go, you're going to end up in the same place, and that's what calculating these forward rates is really all about. So let's march on to the last slide here and wrap up this series of videos. And we're going to look at the shape of the yield curve. We can have a few different possible shapes. A normal yield curve, which would be upward sloping. We can have a steep curve, a steep yield curve, and that's going to be extremely upward sloping. We can have a flat curve, or we can have an inverted curve. This is probably best seen in some examples in your textbook, but we can look at some pictures as well back in Excel on the last sheet. Look at some yield curves over the last 4 years. The oldest one is the blue one. It's also the steepest yield curve. It starts at the lowest number and goes almost as high as the most recent yield curve, but there's the biggest change over the life of over the different maturities. So the 1 month was close to 0. The 30-year was not too far away from 3%. So it had that difference over time, that maturity spread. The most recent one is much flatter. It starts at just a shade under 2% for the short-term rates, the 1-month rate, and it goes to just a little bit over 3% at the longest end of the yield curve. So just a 100 basis point increase over the 30 years as opposed to the 300 basis point increase back in 2015. So the yield curve over time has flattened, and actually flattened quite a bit over the past 4 years, and interest rates have raised as well. So we've got 4 different theories to explain the shape of the yield curve, and I'm going to leave you to look at your textbook and read through each of these theories: the pure expectations theory, the liquidity theory, the preferred habitat theory, and the market segmentation theory. There may be a question on the quiz, a conceptual question. So we're going to stop here, and that will wrap up our discussion of interest rates and the yield curve.